Hello everyone, this is Mridul Agarwal. So today I would be speaking about the screw gauges, but first tell you something about the things that we are going to discuss and everything related to it. Okay, let me share my screen first. So hello everyone, this is Mridul Agarwal. I've done my BTech in mechanical engineering and MTech from IIT Mandi, and then I've been pursuing my PhD in mechanical engineering from IC Bangalore. So today we would be talking about the screw gauges, and I'll be dealing it with deeply. We'll be solving some problems as well in the end stage, and we'll be discussing the things. So first, let me tell you something about me. So uh, my name is Mridul Agarwal. I'm actually teaching uh, physics to the students of JEE Mains, IIT JEE, NEET, UG since 2018 onwards. I have taught around 1000 plus students since 2018, and I've taught at FITG Limited, ICAD Nagpur, and recently at Motion Academy Agra. Currently, I'm pursuing my PhD in mechanical engineering from ISC Bangalore, and I've done my MTech from IIT Mandi in mechanical engineering only. I've been gate qualified multiple times. In the 2024, I got rank AIR 130, 1331. I've cleared the NDA and the FCAT exam. I've also got AIR 86 city rank 1 in Indian Engineering Olympiad. And I've also cleared UPC 2013 exam with a UP general rank of 2642. So there's a lot of things that I've discussed about me, and it must have told you that it's a bit credible to depend on the content that is delivered in this lecture. So, of course, for the online students is also started for the students of class 10 moving to class 11, and for class 11 the students moving to class 12. The duration of each class would be 1 hour 30 minutes. If you want to enroll, you can personally message me or drop a mail on virtualkumar742@gmail.com. And the platform that would be used is Zoom or the Google Meeting. In month basis, around 24 classes per month would be there, and this would be one-to-one type of class, and one free demo class is available, live class is available, regular DPPs and doubt discussion would be there, and I'll try to simulate the things and tell you in a way that you can understand it better. So we'll be using some animations and simulations as well. So today we would be discussing about the screw gauges and the problems regarding it, and this would be a bit lengthier topic. First, we would be discussing the theory involved in it, and then we'll be discussing about the problems based on it. So first, let me tell you about the screw gauge and its components. You must have seen this instrument somewhere in your physics lab. You must have seen that you have this U frame attached with a sleeve, which is attached with the thimble, and then finally you have a ratchet. So this whole is a this whole instrument is known as screw gauge or or micrometer micrometer, and this is a very nice component in terms of measuring the size of the components. Since you have used your daily scale like this, you have 0, then you have 10 divisions like this, and then this is 1. So you generally measure around 0.1 centimeter from this. So by using this screw gauge, you can measure up to higher precision limits, and you can measure up to 10 to the power minus 6 meters. You can also convert it into microns, and this is 1 micrometer only. So you can measure up to higher micrometers precision value, so that you can have a very precise measurement of whatever you are measuring. Okay, so let's say you want to measure a thing that has a dimensions of 2.000 3 meter. Okay, so in such a case you can measure it up to this decimal places, and you can say it like this, that you can measure up to 10 to the power minus 6 into 10 to the power 3 mm per mm. So this is around 10 to the power minus 3 mm. Okay, so this is a very nice component in terms of measuring the components and its size to very high precision value. So we'll be talking about this zero error just some time later. First, we'll discuss about the working of the screw gauge. Okay, let me. Okay, so in front of you, you can see a screw gauge like this. This is a screw gauge, and you have a component like this. Okay, you have a component like this, and you can change the micrometer values according to your requirement. In this case, we are trying to measure the length of this component, and will adjust our linear gauge accordingly. So let me tell you about. Okay, so let me take this example. Uh, we have a component like this, and we want to measure the uh, length of this component. Which length? That is this length we want to measure. We have a linear scale like this. This is your linear scale. This is very important thing that you have to remember. Linear scale, and you have this is your linear scale, and this is your circular scale. This is circular scale. So you must have used screws in your daily life. So you have seen that when you try to rotate the screw, let's say you have a screw like this, and you try to rotate the screw, okay, when you try to rotate the screw, then it goes inwards. Okay, and when it goes inwards, then it has some rotation involved in it. So similarly, what happens over here is when you try to put a component inside it, let's say this component is placed inside it, you try to rotate this, and you get some linear scale reading, and you get some circular scale reading, and depending on that you measure the length and the values for the length of this component. Okay, so we'll measure the length of this component. Let's say this is the dimension d that we want to measure. So how will you measure this dimension? In order to actually identify the length of this component, we'll have two readings. First is the linear scale reading. This is the linear scale reading, and from this we get the main scale divisions, and you can see there's rating like that is written like 1 MSD is equal to, which is equal to 0.5 mm. So this is the one division. So when you are talking about the division, so we can count like this. You can also zoom like this. Yeah. Yeah. So when you are putting this component inside, what happens? Then you measure the linear scale reading. Let me rub this, and you are able to see it clearly. from the linear scale. You measure this 4 divisions. So we have a linear scale reading of 4 MSD. 4 MSD. So this is linear scale reading. So linear scale reading is currently as 4 MSD. And what is the value of 1 MSD? One mean scale division is equal to 0.5 mm. So this is 4 times 0.5 mm. So this becomes 2 mm. Okay. Now we have second reading that we want to take. And this is the circular scale reading. Circular scale reading. So if you can see this 25th division is coinciding with the linear scale. So this is the 25th division that is coinciding. So the circular scale reading is currently 25. And what is the least count of this screw gauge? So for defining the least count of this screw gauge, least count, you have to understand this concept of pitch. Of pitch. So what is pitch? Here we can see that when you rotate it like one time, it moves some linear distance in the direction of the this linear scale movement. So whatever the length that is being traveled by this linear scale, when you rotate it one time, that length is known as the pitch of this screw gauge. So what is the pitch? So this pitch is the linear length traveled by the linear scale on one complete rotation of circular scale. And what we are trying to do is we are trying to divide this pitch by the number of divisions on the circular scale. Why we are doing it? Because we want to find the length of one circular scale division in terms of linear scale in a screw gauge. So this we are going to divide by 50 because we have a CSD count of 50. So what it means, we have only 50 divisions available on this screw gauge. We can also see this like this. You remove this, just a minute, and you remove this. You can see that it's only going to 45 and then 0, isn't it? It is going up to 45 and then 0. Okay. So that it means that it has only 50 divisions involved in a complete rotation. And for a complete rotation, it moves a linear distance of how much? That is pitch. Okay. So let me bring it to the original PV like this. Okay. So the number of divisions involved in one complete rotation of this screw gauge is 50 as per the given condition. Okay. Now this pitch divided by 50 would be our least count because that is the minimum value that we can measure using the screw gauge. So what is the pitch over here? So it is given as 0.5 mm. In any question, it will be given. So here the least count becomes, so least count is pitch divided by 50, and this is 0.5 mm divided by 50. So when you solve this, uh, this becomes, let me rub this. So the least count becomes 0.5 mm divided by 50, that is 0.1 divided by 10, that is 0.01 mm. So depending on your requirement, you can choose the micrometer and you can have a least count accordingly. So here the least count is 0.01 mm. Now what will be the dimension of this component? That was the main objective in finding this dimensions of this object. So what is the dimension of this object? D would be equals to, you have a linear scale reading because it has moved a bit distance like this, and you have also moved some part linearly because of the circular movement of this circular scale. So this is the linear scale reading plus the circular scale reading into these counts. So here zero error is 0. So least linear scale reading is given as 2 mm, and we have circular scale reading as 25 and least count as 0.01. So what is the value of this? So this is 2.25 mm, isn't it? So this is our final reading for the dimensions of this object in a linear value, this D value. Okay. So what we have to do, I'll summarize it again. First, you have to place the component inside it. We have to measure the linear scale reading. Then we have to measure the circular scale reading. And from the linear scale reading and the circular scale reading, we can calculate the dimensions D. And how will you calculate the least count? That least count is equal to the pitch value. Pitch, what is pitch? Pitch is the linear distance moved by the screw gauge on one complete rotations. And then once you find the pitch, you can use the pitch divided by number of divisions on the circular scale to find out the least count. So here we have number of divisions as 50. So we can divide 0.5 by 50 and you get 0.01 mm. So this is your least count in this case. And we have a zero error as 0. So what is this zero error? Let me explain this concept as well. When you bring this circular scale into contact with this linear scale, okay, then what happens? It's possible that at the initial time when you are not measuring the length of any component and you are just putting the, you are just trying to, you are just trying to put these two hands, these two hands, which two hands? These two in contact directly without putting any component in between. Then what happens when you're trying to put these two parts into contact? Then it is possible. Yeah. Now you have bring it into contact. You can see that the zero is coinciding with the zero. The zero of the linear scale is coinciding with the zero of the circular scale. When the zero of the linear scale is coinciding with the zero of the circular scale, then you have no zero error. So you have a zero error. Now suppose spindles, and these two spindles are joined to each other, and we have a zero error in this. Let me show you how. So you can see that over here we can see that this 40 division, this is a completely of a 50 scale division, 50 main scale divisions in this screw gauge, and out of that 40th division is already coinciding with the zero of the circular scale in this case initially, you know. So what is happening is when you are putting no component in between the spindles, then also the 40th division of this zero, 40th division of this circular scale is coinciding with the zero. So somewhere about this zero of this circular scale is above the reference line. So when it is above the reference line, then we have a negative zero error. We have a negative zero error. And by how much this zero of the circular scale is above the zero of the linear scale. So this is by 10 units, you can see that. So we have a negative zero error of minus 10. So when you are taking the readings, then the actual reading would be how much? So that actual reading would be true reading without zero error, without zero error, without zero error, minus negative zero error. So this minus 10 has to be multiplied with the least count, and then it is to be subtracted from the true reading. Okay. Now, if there is a negative zero error, this is your case. When you have a positive zero error, what will be the case? Let me show you this. Now, let's suppose you have a positive zero error of, let's say, 10 units. Then definitely you can see that the zero of the linear scale is coinciding with the 10th unit of the circular scale. So in this case, what happens is these two parts of the spindles are coinciding with each other, but then also the 0th of the linear scale is coinciding with the 10th unit of the circular scale. So in this case, what happens is there is a positive zero error. There is a positive zero error because the zero of the circular scale is lying below the zero of the linear scale by 10 units. So this is the positive zero error of plus 10 into least count, and for the reading to be taken, then you have to take the reading without zero error, without zero error reading, and then you have to subtract this positive zero error. Why we have to subtract and add? This thing is a bit logical, and these are not given in the books also. So, plus first we try to understand why we are subtracting or adding. Let's suppose you are already 10 units above, and when you are putting this object between them, then definitely your reading is going to be increased. Okay, but what happens is whatever reading that you are displaying here, it is already having a zero error of plus 10 into least count, because when this component was not there in between the two spindles, then the zero was not coinciding with the zero, and the 10th division, let me show you, then the 10th division was coinciding with the zero of the linear scale. So in this case, what it shows is that it must have rounded off anti-clockwise from your direction, anti-clockwise, starting from 10. and going to, let's say, 35. So it must have moved only 25 in real sense. Okay, so it must have moved only 25. So you just see that what you are trying to do, you are taking the reading as net reading as 25. Why? Because what you see is 35, but there is a already extension of 10 units when no component was there. So when there is no component between the uh, spindles, you have a 10 unit, and now you are displaying 35 unit. So there must be a rotation of 25 division only. So that's why we are subtracting this positive zero error. In case of the negative zero error, what is happening is, in case of negative zero error, we are already behind. Let's say we are behind 10 divisions. Okay. So what is happening like this? Now, when you are this putting these two spindles together, then what is happening? The 40th unit is displayed and the zero is above. So when you are this, when you are rotating anti-clockwise from your end to put any component in between, then definitely you have to have rotation. And whatever rotation has taken place, let's say it goes from 42, let's say 25 or 35. So what it says now, here it is 15. So how it has gone to 15? So it must have gone to 15 units from 0, and then and that 10 units extra, because you have started from 10 units early, because it was displaying 14. So when you are moving it anti-clockwise, then you are rotating it by 10 and then 15 to get to the point of 15. So actual rotation is 15 plus 10 times of least count. So that's why the positive zero error is coming into place. तो एक बार मैं हिंदी में बता देता हूँ. अगर हम नेगेटिव जीरो एरर की बात कर रहे हैं, नेगेटिव जीरो एरर की केस में क्या हो रहा है कि हम जब भी बात करेंगे नेगेटिव जीरो एरर की, तो नेगेटिव जीरो एरर में जैसे 40 कोइंसाइड कर रहा था, तो यहाँ पे क्या था कि 10 यूनिट अभी आगे जीरो था, और अगर मान लेते हैं 15 रीडिंग दिखा रहा है वो, तो मतलब आप 10 यूनिट ऐड किए होगे इसको एंटी क्लॉकवाइज रोटेट करते हुए, और फिर 15 यूनिट पाए होंगे, तो 10 प्लस 15 कितना हो जाएगा? 25. तो 25 यूनिट आपने जो है वो एंटी क्लॉकवाइज रोटेट किया होगा, और 25 के हिसाब से इसका जीरो एरर सेट हो जाएगा. 25 के हिसाब से इसकी रीडिंग सेट हो जाएगी. जीरो एरर तो नहीं सेट होगा, रीडिंग सेट हो जाएगी. लेकिन अगर मान लेते हैं, मैंने बोला कि ये पहले से 5 यूनिट आगे था और जीरो इसका ऊपर लाई कर रहा था, तो जब जीरो इसका पहले से, या जीरो नीचे से लाई कर रहा था, जीरो नीचे से लाई कर रहा है, तो उस केस में क्या होगा? जीरो जब नीचे से लाई करेगा, तो यहाँ पे बेसिकली जो भी ये डिवीजन दिखा रहा है, उस डिवीजन में से हमें ये 5 डिवीजन घटाने पड़ेंगे, जैसे कि पॉजिटिव जीरो एरर के केस में होता है. तो एक बार मैं दोबारा बता रहा हूँ आपको, जब भी हम पॉजिटिव जीरो एरर की बात करेंगे, तो जो जीरो होगा सर्कुलर स्केल का, वो लीनियर स्केल के रेफरेंस लाइन से ऊपर होगा. और जब भी हम नेगेटिव जीरो एरर की बात करेंगे, तो जो भी जीरो होगा सर्कुलर स्केल का, वो लीनियर स्केल के रेफरेंस लाइन से नीचे होगा. तो जब ये नीचे है और अब आपके पास कोई रीडिंग है, तो वो रीडिंग में आपको ये 10 रीडिंग या 15 रीडिंग जो पहले से पीछे थी, वो भी ऐड करनी पड़ेगी. तो इसीलिए नेगेटिव जीरो एरर के केस में हमें ऐड करना पड़ता है. और पॉजिटिव जीरो एरर के केस में क्या हो रहा है, क्योंकि ये पहले से 5 रीडिंग ऊपर है और जीरो इसका नीचे लाई कर रहा है, जब जीरो सर्कुलर स्केल का नीचे लाई कर रहा है तो 5 यूनिट ये पहले से ऊपर हो सकता है या 10 यूनिट हो सकता है, जो भी है। और मान लेते हैं ये 25 दिखा रहा है, तो अब यहाँ पे केवल रोटेशन हुआ होगा 25 माइनस 10, मतलब 15 का। इस केस में 15 का रोटेशन हुआ होगा जब हमारे पास पॉजिटिव जीरो एरर है, और जब हमारे पास नेगेटिव जीरो एरर है तो उस केस में हमारा जो रोटेशन है वो ज्यादा हुआ होगा। अगर ये मान लेते हैं 40 भी दिखा रहा होता तो हो सकता है 15 तक आने के लिए पहले 40 से जीरो पे जाता, फिर उसके बाद जीरो से 10 पे आता, तो 10 प्लस 10 कितना हो जाता, 20। यहाँ पे रीडिंग जो है वो आपको लेनी पड़ती। ठीक है, वो भी आपको जीरो एरर का कॉन्सेप्ट समझ में आया होगा। अभी हम प्रॉब्लम करेंगे तो और ज्यादा अच्छे से क्लियर हो जाएगा। चलिए देखते हैं यहाँ पे। मान लेते हैं आपके पास ये पहली प्रॉब्लम है। आपको क्वेश्चन में दिया हुआ है कि 10 rotations of the cap of the screw gauge is equivalent to 10 rotations of the cap of the screw gauge is equivalent to 5 mm. So for one rotation we have to find the pitch. So one for one rotation pitch कितना होगा? अगर मैं pitch की बात करूं तो one rotation के लिए pitch कितना हो जाएगा? 5 mm divided by कितना हो गया? 10। तो ये कितना हो जाएगा आपका? 0.5 mm। तो ये हो गया आपका pitch। ठीक है, द कैप हैज 100 डिविजन्स। तो यहाँ पे अगर हम देखें नंबर ऑफ डिविजन्स कितने हैं, नंबर ऑफ डिविजन्स ऑन सर्कुलर स्केल कितना है, तो हम देख पा रहे हैं ये 100 डिविजन्स है। तो यहाँ पे लीस्ट काउंट कितना हो जाएगा? लीस्ट काउंट मैंने बताया था आपको, पिच अपॉन नंबर ऑफ डिविजन्स, यही होता है। तो ये कितना हो जाएगा? ये हो जाएगा आपका पिच कितना है आपका 0.5 mm डिवाइडेड बाय हम क्या कर देंगे यहाँ पे 100 से, तो ये कितना आ जाएगा 0.005 mm। ओके, अब यहाँ पे अगर हम देखें क्या दिया है, a reading taken for the diameter of the wire with the screw gauge shows 4 complete rotations and 35 divisions on the circular scale। तो diameter of the wire हमको फाइंड, तो हम डायमीटर कैसे फाइंड करते हैं, डायमीटर वायर का कैसे फाइंड करेंगे? तो डायमीटर के लिए रीडिंग हो गई अगे, और हमने बताया था आपको लीनियर स्केल रीडिंग प्लस यहाँ पे सर्कुलर स्केल रीडिंग इनटू क्या कर देंगे, लीस्ट काउंट। तो यहाँ पे अगर हम देखें तो ये सिंपल सॉल्व हो जाएगा। लीनियर स्केल रीडिंग आपकी कितनी है, क्योंकि क्या कह रहा है ये 4 कंप्लीट रोटेशन। तो 4 कंप्लीट रोटेशन मतलब एक कंप्लीट रोटेशन में पिच के बराबर मूवमेंट करता है, तो 4 रोटेशन के ये कितना हो जाएगा 4 इंटू 0.5 mm प्लस सर्कुलर स्केल रीडिंग कितनी है इसकी 35, और लीस्ट काउंट कितना है इसका 0.005 mm। तो अगर मैं यहाँ पे सॉल्व करता हूँ ये कितना बन जाएगा, ये अगर मैं सॉल्व करता हूँ तो ये आ जाएगा 4 टाइम्स 0.5 प्लस 35 इंटू 0.005, तो ये आ जाएगा 2.175। तो ये इसका फाइनल डायमीटर होगा, डायमीटर ऑफ द वायर। ठीक है, वो भी आपको पॉइंट क्लियर हो गया होगा। नेक्स्ट क्वेश्चन करते हैं। नेक्स्ट क्वेश्चन दिया है कि सर्कुलर हेड ऑफ द स्क्रू गेज इज डिवाइडेड इनटू 200 डिविजन्स and move 1 mm ahead in one revolution if the same instrument has a zero error of minus 0.05 mm. The reading on the main scale in measuring the diameter of the wire is 6 mm, then and that on the circular scale is 45। Find the diameter of the wire। अगर हम यहाँ पे ध्यान से देखें कैसे बना सकते हैं इस क्वेश्चन को, तो देखिए कितने डिविजन दिए हुए हैं। The circular divisions of the screw gauge is divided into 200 divisions। तो यहाँ पे नंबर ऑफ डिविजन्स हो जाएंगे, नंबर ऑफ डिविजन्स ऑन सर्कुलर स्केल कितना हो जाएगा यहाँ पे, ये हो जाएगा 200। और यहाँ पे पिच जो दिया है, ये पिच इसने दिया है 1 mm अहेड। तो अगर मैं लीस्ट काउंट निकालना चाहूँ तो लीस्ट काउंट कितना हो जाएगा 1 mm डिवाइडेड बाई 200। तो ये कितना हो जाएगा, ये हो गया 0.005। ये हो गया लीस्ट काउंट। इफ द सेम इंस्ट्रूमेंट हैज अ जीरो एरर ऑफ -0.05 mm, हमको पता है ये -0.05 mm है, तो इसका मतलब हमें ऐड करना है। द रीडिंग ऑन द मेन स्केल इन मेजरिंग द डायमीटर ऑफ द वायर इज 6 mm and that of the circular scale is 45। डायमीटर निकालना है। तो यहाँ पे अगर मेरे को डायमीटर निकालना है, कैसे निकालेंगे डायमीटर, तो हमको पता है डायमीटर के लिए क्या करेंगे, जो मेन स्केल रीडिंग है वो कितनी है 6 mm, प्लस दैट ऑन द सर्कुलर स्केल कितनी है 45 इंटू लीस्ट काउंट कितना है 0.005 mm। और हमको पता है यहाँ पे इस इंस्ट्रूमेंट के पास जीरो एरर कितने का है -0.05 का है, तो इसको हम सब्ट्रैक्ट कर देंगे। तो यहाँ पे कितना आ जाएगा 6 + 45 टाइम्स 0.005 0.05, तो ये हो जाएगा 6.275 mm। तो यहाँ पे जो डायमीटर ऑफ द वायर आया है वो कितना है 6.275 mm। वो भी आपको क्लियर हो गया होगा। नेक्स्ट क्वेश्चन करते हैं। नेक्स्ट क्वेश्चन दिया है कि डेंसिटी ऑफ द सॉलिड बॉल इज टू बी डिटरमाइंड इन एन एक्सप्रेशन। डेंसिटी निकालनी है। डेंसिटी होता है किसी भी सॉलिड बॉल या किसी भी ऑब्जेक्ट का डेंसिटी क्या होता है, मास अपॉन वॉल्यूम। ठीक है। द डायमीटर ऑफ द बॉल इज मेजर्ड विद स्क्रू गेज हुज पिच इज, इसका पिच दिया हुआ है आपको 0.5 mm, और देयर आर 50 डिविजन ऑन द सर्कुलर स्केल। तो नंबर ऑफ डिविजन कितने हो गए सर्कुलर स्केल पे, यहाँ पे ये 50 डिविजन। द रीडिंग ऑन द मेन स्केल इज 2.5 mm। तो जो मेन स्केल रीडिंग है वो आपको पता है, कितनी पता है 2.5 mm, एंड दैट ऑन द सर्कुलर स्केल इज 20 डिवीजन। सर्कुलर स्केल रीडिंग भी आपको पता है ये कितनी है 20 है। मेजर्ड मास एज अ परसेंटेज एरर, तो रिलेटिव एरर परसेंटेज एरर इन द डेंसिटी भी निकालना है। ठीक है। तो यहाँ पे अगर हम देखें कैसे कर सकते हैं इसे, तो बस परसेंटेज एरर इन डेंसिटी आपको निकालना है, तो इसके ऊपर फोकस करते हैं। तो पहले हम डायमीटर निकाल लेते हैं। डायमीटर कितना हो जाएगा, तो अगर मैं डायमीटर निकालना चाहता हूँ तो डायमीटर कितना हो जाएगा, मेन स्केल रीडिंग प्लस सर्कुलर स्केल रीडिंग। सर्कुलर स्केल रीडिंग कितनी है 20 इंटू लीस्ट काउंट कितना है, लीस्ट काउंट है इसका 0.5 mm डिवाइडेड बाय 50। क्योंकि ये 0.5 mm क्या हो गया पिच, और 50 क्या हो जाएगा आपका नंबर ऑफ डिविजन ऑन द सर्कुलर स्केल। ये आपका आ गया। देन अगर हम देखें यहाँ पे ये वैल्यू कितनी आ जाएगी डायमीटर की 2.5 प्लस, तो ये आ जाएगा 2.7 m। ये डायमीटर आ गई। अगर मैं यहाँ पे देखूं तो कितना, अगर डायमीटर में एरर कितना आ सकता है, तो डेल्टा डी कितना हो सकता है, अगर हम देखें तो वो लीस्ट काउंट के बराबर हो सकता है। तो लीस्ट काउंट कितना है इसका 0.5 डिवाइडेड बाय 50, जो हो गया 0.01 mm का एरर। हमको पता है एरर कैसे निकालते हैं, जैसे डेंसिटी जो होता है वो होता है मास अपॉन वॉल्यूम। तो डेंसिटी अगर मैं रो से रिप्रेजेंट करता हूँ तो मास m अपॉन कितना हो जाएगा वॉल्यूम 4/3 पाई r³ या फिर d/2 का होल क्यूब। अगर मैं देखूं यहाँ पे तो जो भी एरर होगा डेल्टा रो बाय रो कितना हो जाएगा डेल्टा m/m प्लस कितना हो जाएगा 3 इंटू डेल्टा d/d, क्योंकि हमें मालूम है कांस्टेंट कोई भी नहीं लेते हैं एरर। अगर मैं परसेंटेज एरर डेल्टा रो बाय रो निकालना चाहता हूँ तो कैसे निकालूंगा? परसेंटेज एरर इन मास आपको दिया है 2% प्लस 3 इंटू कितना परसेंटेज एरर है डायमीटर के अंदर, तो ये है 0.01, कितने पे? 2.7 पे। तो ये कितना हो गया आपका? इसको मैं परसेंटेज में लिख दे रहा हूँ। ये हो गया 1.11% का मतलब अभी यहाँ पे हमने फ्रैक्शन निकाला है, इनटू क्या करना पड़ेगा? 100 करना पड़ेगा। तो यहाँ से जो वैल्यू आ जाएगी आपकी, जो परसेंटेज एरर है, जैसे अगर मैं देखता हूँ तो परसेंटेज एरर कितना आ जाएगा, डेल्टा रो बाय रो कितना आ जाएगा आपका? ये आ जाएगा आपका 1.11%। ओके, तो ये जो है वन सॉरी 1.11% नहीं होगा ये। अब सॉल्व कर लेते हैं पूरा, तो कितना बनेगा? एक बार ये अगर मैं सॉल्व करता हूँ, हाँ, ये जो आपका वैल्यू बनेगा, ये बन जाएगा 3.11%। 3.11%। तो ये जो होगा ये परसेंटेज एरर हो जाएगा किसके अंदर? डेंसिटी के अंदर। और इस तरीके से हम ये क्वेश्चन सॉल्व कर सकते हैं। तो ध्यान रखिएगा, जब भी हम यहाँ पे देखते हैं तो जो भी एरर बनेगा किसी वैल्यू में जो आपने मेजर किया है, वो कैसे निकालेंगे? वो एरर हम निकालते हैं बेसिकली जो भी इसका लीस्ट काउंट एरर है। लीस्ट काउंट एरर कितना है? जितना उसका लीस्ट काउंट है, उसका लीस्ट काउंट डिवाइडेड बाय जितना उसकी वैल्यू है ना। तो यहाँ पे हमने ये पूरा सॉल्व किया है। होप ये आपको समझ में आया होगा। और अगर आपको कोई भी डाउट हो, कोई भी प्रॉब्लम हो, तो आप मेरे को मेल कर सकते हो, मैसेज कर सकते हो। और प्लीज़ इस वीडियो को अगर आपको अच्छा लगे तो प्लीज़ लाइक करिएगा, शेयर करिएगा और सब्सक्राइब करिएगा इस चैनल को। मैं लगातार यहाँ पे वीडियो डालता रहूँगा। नेक्स्ट लेक्चर में हम लोग लॉज ऑफ मोशन की बात करेंगे। होप ये टॉपिक आपको काफ़ी अच्छा लगा होगा और हम आगे भी डिस्कशन करते रहेंगे। सो थैंक्स फॉर लिसनिंग। डू लाइक, शेयर एंड सब्सक्राइब माय YouTube channel so that I can be motivated much more and make more videos that can help you in your studies. Thanks.